Hi folks, I think I've seen a lot of you before, and hopefully you've seen me before. I've been here last Christmas, I think it was, anyway. My name's Peter Dennis, in case you don't know me. Peter Dennis, I work for Solaris Revenue Product Engineering. We're the guys who do all the sustaining, so we produce the patches, the SIUs for Solaris. And my talk today is dissecting the Package 5 manifest, i.e. having a look at the manifest, what's in it, what's it do. And out of interest, how many of you use Oracle Solaris 11? How many are just Solaris 10 people? And you're all eager to move on to Solaris 11. Okay. Feel free to ask questions at any point, at any time. We can digress and go off into anything else, I don't mind. And then I'll just say I don't know the answer, so I don't mind, I don't know. So anyway, quickly what the agenda is here. So a very quick overview for packaging, because I know some of you have had it before, you don't have to go through all of the old ground. But then I'll go through the manifest and intro, what it is, and I'll just cover some of the simple bits that's in the manifest, and then some standard actions, the files and directories, and then some more interesting actions. And then we'll go into dependencies. Dependencies seems to be quite a interesting topic in terms of usability for Solaris 11, simply because if you try to install a package and dependencies are violated, then it just gives you this massive error message. And what I found, just experience-wise, talking to people, is they don't understand what dependencies actually mean. And if you understand what dependencies mean, then you understand why they're being violated, then you hopefully will understand a bit more about the error messages. Then I'll put something about advanced bits. We'll see about that. And then this wonderful term called actuators. Personally, I don't like the term actuators because it's meaningless to me, but we've got it there. And then I'll give a usage example of something, the way that the sustaining team have used packaging in order to make things a little bit easier for customers. And then if we have some time, then I've got some online demos to just run through. So, moving on. Very quickly, packaging overview. The new packaging system in Solaris 11. Actually, Solaris 11 has been out quite a while now, and we had previous releases there. It's based on an image system, so the install set of packages we have on the system is always going to be consistent. They're always going to be the ones that we've tested and built together. Rely on a network repository, so you can get packages out of an HTTP, HTTPS, or a file-based repo. None of these sorts of like tarbors that you get. It's a one-tier packaging system. That's actually quite a fundamental change that we've had here. So we have no more SVR4 packages like we do in the Solaris 10 world. We just have an updated package. But also we have packages that are just fat packages. They deliver both x86 and Spark, which actually makes things a lot easier going forward. And one of the other things we don't have is class action scripts. So the SVR4 supports class action scripts. Whilst they might seem to be really good and cool things, they're a demon to test and get right. You think of, all right, I'm just going to do a class action script for this package, add it to our system, it works. Some customer out there is going to think of some different way of using that package, and it's just going to fall over in a heap. By not having class action scripts, we eliminate that whole problem, and we replace it by what we call SMF actuators. It's not just a delivery system, it's also a development system, so we deliver both the client-side tools for installing packages, but also developer tools for actually allowing you to build packages, convert SVR4 to IPS packages, and also tools to allow you to check for consistency within the packages themselves. And then there's a list of commands here, PKG, the normal client side, PKG repo, so you can create repositories and administer them on your machine, PKG send for actually publishing to the repository, PKG receive to suck packages from a repository and do whatever you want to do with them, republish them, PKG mogrify, that's a lovely command, that allows you to edit package via scripts. So you've got 1,000 packages and you want to put in an action in all of them rather than going VI, blah, blah, blah. You just use PKG mogrify, make a transform, it just goes on and does it all for you. And that is actually, we use that for building Solaris. So we have a whole bunch of transforms that inject standard stuff, and it just goes in and says, okay, I'll put this in all the packages. So for example, when we build kernel components, rather than having to put one of the special tags in there reboot required, we say, oh, this is a kernel component, we just slap it in as part of the transform. So effectively we just have one line script over that. PKG lint, that just checks the consistency for your package, make sure you've not broken anything, i.e. you're not trying to deliver multiple versions of the same file. A really, really, really useful man page is the PKG5 man page. There's a huge amount of information in there, it tells you all about the fMRI stuff, about the actuators, about the stuff that is in the manifest. So I would actually encourage people to give that a good read. Any questions on that one? No? Right. So we'll jump straight in. Here's a manifest. What I intend to do is go through each word on this as we go along, so that's going to take about 2 hours. So
version string.
Yeah, so we're all happy about that?
Yep.
Yep, okay. So the first word is set, then it's name. Okay, I'll forget that. This is just a manifest, so that's just an example of stuff in there. So when you do look at a manifest, you see all this stuff go past, and you'll find there's lots of stuff in there. So what I intend to do here is actually go through a bunch of this, but not like looking at this one, but just pick out the things that are relevant and interesting from, I think, from my perspective, maybe from your perspective. If I've missed something, then just ask a question about it. Okay, so the first question is, what is a manifest? A manifest describes what is being installed on your system. So it's actually what binaries you're going to have, what directories, what users, a whole bunch of stuff. It's actually the content that makes up your system. And you can have a look at the manifest using the pkg client command, which is pkg contents. If you do normally pkg contents, it just lists all the files that are in there. If you use the -m option that I have here, that actually says, go tell me the manifest. So in this case, I'm just saying, look at system library, pipe through more, and tells me what we can see there. If you don't want to use the command line, you can use the web browser. Just go to the repo, click on manifest, and you effectively see the same thing in your web browser. Nothing special there. Effectively, the manifest entries are a set of actions. So there's, in this particular case, we have a set action which says it's a name-value pair. So say the name of this thing is so-and-so, and the value of this thing is so-and-so. So we'll just dig into some of the standard ones here. So obviously, the very first line we see in the package is the name package. So this is where I get to say set name package. So we have the pkg fMRI. That has to be in the package. If you don't have pkg fMRI in your package, then you won't be able to publish it because you don't know how to call it. So then we say the name, the value, in this case is system library, and then we have the fMRI string. If you really want me to tell you all about the fMRI string, I can do. Hands up who wants me to tell you about the fMRI string. Hands up who doesn't. Okay. So effectively, set things very simple. You say this is the name, and then you set the value associated with it. And again, the fMRI fault management resource identifier uniquely identifies that package name and the version with it. The exact syntax is documented in the pkg5 command page. That's really simple. So we have a table here of all the other associated bits. So we want to tell somebody what is the purpose of this package. So we say pkg summary. It tells you a brief description of this package. pkg description gives you, write a novel if you want, tells you what this package does and so forth. One of the other interesting bits, because we have the fMRI, which is made from digits, we have open source components which don't use digits, they might use alphanumerics. So it might be, so for example, OpenSSL is 1.0.1.j or something. J doesn't fit into the fMRI thing, so what we have to do is put a human version in there. And in that, apart from the Solaris point of view, we inject the alphanumeric version string. So if you look at the fMRI and say, well, I don't really understand that, look at the human version, and then it actually gives you what the FOS component is. And we use that in the support repository updates. I can give an example of that later. You have two other interesting bits, obsolete and rename. These are actually quite clever little bits. Because what we have within the packaging system is a life cycle of how the package lives on your system. It's just not install the package and you're done. Actually, you install the package, it might be end of life, it might be replaced, it might be refactored, and we can use these attributes to actually describe the life cycle of the package. I'll give an example of that later. Some more standard actions. So the first thing we want to do on our system is deliver some directories. I think fairly simple. You say group, mode, owner, path. I think that's all fairly self-explanatory. The interesting bit is, again, we have a fat package. As I said earlier, we have packages deliver both Spark and x86. So in this case, we can see that this package delivers a Spark version and an x86 version. So when you install it on your system, it says, oh, actually, I know you are an x86 machine, so it'll only install that directory. It won't install that one. As I said there, and variant.arch actually tells us what architecture we're living on. So this one tells us this is x86, that one's Spark. So one of the other key things about the packaging system is when you install a package, it has to go through all the actions that are in the package. It has to say, right, I've got to look at this action, I now need to go say that's something I've got to do, and it goes off and you see that it's doing that little spinny wheel things to calculating actions. One other thing is it's calculating the work it needs to do on directories. Yeah? So if you, in every package, say in SVR4 world, we built in our SVR4 package, we put all the directories in packages and we replicated that same directory in all the packages. And in first instance, we did a lot of that in Solaris, is actually replicate that same thing. So we've got a whole bunch of packages all delivering the same directories, which then means from a PKG client point of view, it says, I've got to deliver this directory, okay, put that there. Oh, I've got to deliver it again, I'll go put that there. So we've actually got multiple actions, which actually ends up slowing down to a little bit the packaging client. So one of the best practices is just have one package that delivers your directories and just leave the rest up to just being your normal binary paths. So we are going to be working on Solaris to actually get rid of those. Any questions about that one? Am I talking too fast? No? A little bit. Right, delivering files. So when we look at a system, a file is basically a binary or a shell script or something. It's actually the content we want on the disk. So in the first instance here, we have file. That's our action. It says we're delivering file. Then we have a hash. That's actually the payload of the system. If you want me to go into the structure of how the repo is made up, I can do, but effectively that's an index into the repo, the place where you get your packages from, an index into where that file is. It just pulls it across. Okay. Then we have a couple of hashes. They actually tell us when that file has changed. So one of the key things about PKG is when you install a package, it only installs different things. How does it know something's different? The alpha hash will have changed. So what it does, it looks at the alpha hashes and says, ah, has this changed this package? Fine, I don't need to get that content. So then we have a whole bunch of other attributes here. So it tells us this one's a Spark thing, it's a 64-bit binary. There's nothing really contentious in there, and we just have the general group mode ownership path. There's nothing really overly special in there. When you build a package or look at it, you won't be putting the hash. That's part of the generation or publishing. It actually builds up the hash for you.
Question. Have you actually seen any hash collisions yet?
The answer would be no.
I mean, that's supposed to be
one of the things that, so the algorithm will be changing at some point to use SHA-256. I don't know the details of it, but at this time we haven't seen any collisions whatsoever. Theoretically possible, but
so that's actually more than just a checksum. It's actually pointing to a location sort as well.
This one is.
Yep.
So remind me that question later. We're going to have a look at packaging and we'll just have a quick look and see what the details are. But essentially, the first two digits are your directory index, and then your file is your file. Okay, files also have attributes. So I showed you on the previous page, that's a simple delivery of a file. What we can do, we know that files are, you have configuration files, you have driver configuration files. So what we can do is we know customers go in and edit those. So in the old SVR4 world, we marked a file as editable. In IPS world, we actually have these things called a preserve. We can actually put a preserve tag on there. What that means is if the value is named as renamed, or actually, sorry, preserve tells you what's happened to the file when you come in and install a new version of that file, or try to. So it defines what happens. If its value is renamed old, the current file is named filename.old. If it's renamed new, file name is just set as rename new. Sorry, the new file is installed as rename new, so you can preserve the existing installation. Legacy, that means it's just an old file. We're not going to actually install it on the initial package, but if it is there, then it gets renamed filename.legacy. So that allows us to deliver a configuration files that can be edited. So the other thing we found is some customers said, well actually we want to build our own IPS packages, we want to deliver our own configuration files via IPS. Now one of the things that IPS doesn't allow you to do is say, this package is delivering a file, this package is delivering this file. If you have those two packages trying to install at the same time, It says, can't do it. It just stops you doing it dead because it breaks the integrity of the system.